Welcome back, math fans. Where we left off is we just finished examples 1 and 2. We'll be doing example 3 now, taking a look at this where we have y equals f of x, and this function is 3 times x minus 1 squared. So we have x minus 1 squared like that. And we're going to investigate it using the points. This is going to grow really fast, so we're going to get off the grid really quickly. So we'll probably want 2 above, 2 below. So this is going to be between -1. We're going to look at x between -1 and 3. We're going to try that out. Let's build our table of values. So x and y equals f of x. Building our table of values here. And we know that this will start at 1, so we're just going to start at 1 right in the center, and that'll make 0, right? 1 minus 1 is 0, 0 squared is 0, 0 times 3 is 0. Let's put in 0, -1, and 2, and 3. 0 minus 1 is -1, -1 squared is 1, 1 times 3 is 3. So that'll work for 2 as well by symmetry, right? 2 minus 1 is also 1. 1 squared is 1 times 1. 3 is 3. All right, let's do this for 3. 3 minus 2 is, 3 minus 1 is 2. 2 squared is 4. And then 4 times 3 is 12. By symmetry, this will also be 12. So this is going to grow off our, this will grow very quickly. So when we make our graph here, let's make sure that we have enough room to at least get to 12. So I'll be very intentional about building this. So 13, 12, 11, 10, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, 2. All right. Just to give myself a lot of room here, right? A lot of room just so that we can see at least 5 points on this thing, just so that we can get motoring along here. Right, x, y, and when we're doing this, we'll get, let's place our points. So our vertex now is at 1 and 0, right? So here's the vertex at 1 and 0. Axis of symmetry is on x equals 1 as well. 2 and 3 is right here. 0 and 3 is right there, so that's also our y-intercept. And our next one is at 12 here, so that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right there. Good. Lots of room. And by symmetry, it's going to show up right here. And our vertex is always halfway between our symmetry points, right? So if you see here and here, they're both, the vertex is 2 away from each of those, right? Here and here, the vertex is 1 away. Even if I were to pick different parts on the line, you would see that it's the same distance away, right? So if I drew a horizontal line through the parabola, that at any between the parabola, that the vertex axis of symmetry is always going to be halfway where that horizontal line intersects the parabola. So I'll show you exactly what I mean by that in a strict mathematical definition. So it gets a bit harder to sketch as they get like really narrow like that, right? As they get narrower, it's harder to indicate that it like curves so much faster. When I was talking about if I drew a horizontal line, so like an arbitrary horizontal line like that, then it means that anywhere I draw that horizontal line, that the axis of symmetry is going to be on the halfway point. And we're going to make use of that idea as well. So let's do some interesting solving. So example 4. So with example 4 here, we're going to look at y equals ax minus h squared. We want to find that equation. And what we do know is that we have a vertex at -3 and 0. So this is going to tell us something about our h value. And we have a y-int at 0 and, actually, let's just say a y-int at 2, right? And let's interpret that. So what this means here is that we're that for us, this here, Vx is always h, right? So that means Vx, as a conclusion here, Vx is equal to h. So the x component of our vertex is h. We're going to interpret this to mean 0, -2 is a point on our parabola. So the first thing we're going to do is just take that point we have for free. So that -3 is actually our h value. So just get that out of the way first. We'll get y equals a x minus -3 all squared. Well, that's just going to be plus 3. So y equals a x plus 3 squared, like that. Now we have this point here that we can use as our finding for a, right? That's an xy point, xy, so we can use those values together. Substituting that in, now this is going to be 2. That a is still there. We're trying to solve for that. This will be 0 plus 3 squared. And just as to color code it here, that'll be where I got that. That's replacing x, that's replacing y. I'm going to end up with 2 equals 3 squared. And this gets to be 2 equals 9a, or a is equal to 2 over 9. Just like that. So putting this all together, I will get, right, a final solution here of y equals 2 over 9 x plus 3 squared. And that is the equation for that parabola with those conditions. Let's do one more, example 5, and then good job, math fans, going through, just like looking at these parabolas in a large amount of detail. If we have 3 and -5 is a point on the parabola. So we don't know where exactly, if it's a major point or if it's just a point. So we have 3, -5 is on the parabola. And all right, it tells us the parabola is y equals a x plus 1 squared. So it says name another point. Or let's just let's find a and name another point. So what we're going to do is, we know that this is an x, that's a y, and we get given the h value already. Just let's go ahead and do some fun solving. This is -5. A we don't know. This is 3 plus 1 squared, like that. We'll get -5 equals a, and that'll be 3 plus 1 is 4. That'll be 16. So I'll get -5 is equal to 16a. And with that, a will be equal to -5 over 16. All right, so we have an a value over there. Actually, thinking about this now, sure, we can find the a value, and we'll get another point here where y equals -5 over 16 x plus 1 squared. But really, let's actually stop a moment and consider symmetry, right? If I'm looking at symmetry, 1 and 3 are 2 units apart, or 2 x units apart, right? Or 2 like x spaces apart. And I know the vertex axis of symmetry is somewhere. So what I'm going to do is, let's actually graph this and make it visual, because I think the visual demonstration will be very helpful for us here. And I'm going to graph that axis of symmetry first. And I don't have enough to graph I can graph this parabola, but it's not going to be very nice. But let's talk about where the axis of symmetry is. That's at -1. So the axis of symmetry here is at -1. Oh, and it's going to be, so axis of symmetry here is at -1. So the axis of symmetry here is at -1. Let's say I have this point at 3 and negative 5. 1, 2, 3, 4, 5. So here's my point at 3 and negative 5. Let's use the axis of symmetry to our advantage. This here has a distance of 4 units. I made a mistake to start with, but this is 4 units right there. What that means is I'm going to be able to get another point on this parabola, right? I want to get another point on this parabola. That should be the direction that I have on this question, is we're ultimately trying to get another point. But the next point here is going to be 4 over there. By axis of symmetry, I'm going to have another point right here. So what that means, I don't even need to know where the vertex is. As long as I know where the axis of symmetry is, I know that these 2 points are going to be symmetrical and this will work out. So what happens is that this point here is, let's see, that's an x value of negative 5. So this is negative 5 and 5 is that point. So what happens is that this is an entirely different point. Sure, it has, oh wait, this is 3 and negative 5? Ooh, okay, hold on. Same thing applies. Let's just make this 3 and 5. The same idea applies, is that it'd still be just negative 4 away from there. So the other point could be at negative 5 and 5. If I was at 3 and negative 5 like I originally should have been, if I had a parabola that did that, the same logic would apply to make that correct as well at negative 5 and 5. All right, so it's just about using that axis of symmetry to our advantage there. I'll look for the rest of the videos to be completed shortly. Just bear with me. All right, have a great day, math fans.